Alrighty, Roo, here we go. We're talking about installment number 115. So we're going to do some questions now that deal with proving conjectures. Okay, let's have a look. Same stuff we focused on last time, same kind of things. We're going to leave out the two-column proof questions for now, though, as we stated in our last section, because these two-column proofs are more of a focus of the next unit. I just want to introduce them here. I wanted to, rather, while we're just sort of looking at proofs anyway. But we'll get back to that. Which represents the sum of the squares of two consecutive odd integers. Okay, so let's see. Remember, if we said x was an integer, an odd integer, well, we get an even integer by calling it 2x, and then we get an odd integer by calling it 2x plus 1. But we want two consecutive odd integers, so the next odd integer would be 2 more than that, right? Because let's say we're at 5, the next one would be at 7, which is 2 more. If we're at 11, we'd go to 13, which is 2 more. So 2 more than 2x plus 1 would be 2x plus 3. So we want the sum of the squares of two consecutive odd integers. So we want 2x plus 1 squared, and the sum means to add them together, and 2x plus 3 squared. So that looks like B. This one, oh, they forgot to double the x's, and this one they got the squares in the wrong place. And in this one they factored out the 2 and didn't apply it to the 1 or the 3. Oh yeah, just weird. So the only answer is B. Okay. Prove that the sum of any 5 consecutive numbers is a number that is divisible by 5. Okay, let's try that. 5 consecutive numbers. So x is our first number, x plus 1 will be our second, x plus 2 will be our third, x plus 3, and then I guess the last one would be x plus 4. So 4 more than the first would be the fifth one. So prove that the sum of those is a number that is divisible by 5. So we have x, and then we have to add x plus 1, and x plus 2, and x plus 3, and x plus 4. We have to show that that's a number that's divisible by 5. So just a little side note here. If a number is divisible by 5, then you should be able to break it down into, so let's take a look at a number that's divisible by 5, like 50. You should be able to break that down into 5 and some other factor. So if we're trying to show that a number that's got an algebraic representation like this is divisible by 5, we should be able to break it down into 5 and then any other expression that's just a number. So let's see what we can do here. So the first thing I'm going to do is simplify this expression. So I want x, 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 and x. That's 5 x's. Plus whatever else we have. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10. Aha, so 5x plus 10, does that have a factor of 5? It sure does. So I have 5 outside of x plus 2. Okay, so then we can just write a little conclusion. Since x plus 2 is an integer, it's one of the ones we started with, isn't it? Doesn't really have to be, it just says consecutive numbers, but whatever. Integer, then 5 outside of x plus 2 is divisible by 5. Okay, little conclusion. And that shows that any 5 consecutive numbers are divisible by 5. Quaderat demonstrandum. We have proven it. Okay, so make sure when you're doing proofs that you always do a generalization using a variable. You don't just do examples. Examples don't prove anything, okay? All they show is that, yeah, it works for at least one other example. But when we're trying to prove a conjecture, we want to show that it works generally for anything at all. And remember, the two-column proofs that we saw in the last section, won't get into those in more detail until the next unit, okay? Alrighty. Hope that's helpful. See you in the next one.